Hello everyone, my name is Catherine I. Merca, a faculty of the Department of Mathematics and Statistics, College of Science and Mathematics. Today, we will discuss about algebraic equations. Our first topic is on linear equations. Our learning objective is for you to be able to solve linear equations. We define an algebraic equation to be an equality of two algebraic expressions. For example, we have x squared plus 4 equals 4x, 5x over 5 equals x, and we have the third example here, 4x minus 7 equals 4 times the quantity x minus 1 closed quantity plus 3. Notice that x squared plus 4 equals 4x is not a linear equation, but it is an algebraic equation. The domain is the set of numbers for which an equation is defined. The set of numbers for which the equation is true is called its solution set, denoted by SS. The elements of the solution set are called solutions or roots of the equation. These numbers are said to satisfy the equation. There are several types of equations. An equation for which the solution set is true for at least one real number is called a conditional equation. Equation 1 in the previous example is conditional. That is x squared plus 4 is equal to 4x. Another type of equation is an identity. An identity is an equation for which the solution set is true for all real numbers. For example, we have 5x over 5 is equal to x. Notice that 5 over 5 will give us 1, so we actually have x is equal to x. An equation that is not true for any real number is called an inconsistent equation. Equation 3 in the previous example is inconsistent. Notice that if we try to solve this out, later on, you will find out that this will not be an equality. A polynomial equation in the variable x is given by a sub n x to the n plus a sub n minus 1 times x to the n minus 1 plus and so on, denoted by 3 dots, plus a sub 1 x plus a sub 0 is equal to 0, where the a sub i's are constants and n is greater than or equal to 1. The fundamental theorem of algebra states that every polynomial equation, a sub n, x to the n plus a sub n minus 1, x to the n minus 1, plus and so on, denoted by 3 dots here, plus a sub 1x plus a sub 0 is equal to 0, where the a sub i's are constants and n is greater than or equal to 1, has at least one complex root. A linear equation is a first-degree polynomial equation in the variable x. That is, an equation that can be written in the form ax plus b is equal to 0, where a and b are real numbers and a is not equal to 0. We now try to generate equivalent equations. So, how do we do that? First, simplify an expression by removing grouping symbols and combining like terms. So we can actually get rid of the parentheses here and solve for the following. 2 times quantity x minus 4 closed quantity will give us 2x minus, this is 2 times negative 4, that's negative 8, plus 3 is equal to 7x. And then we try to combine like terms. Negative 8 plus 3 here will give us negative 5. Followed by, you can add or subtract the same real number or variable expression on both sides of the equation. This time, we subtract 2x on both sides to get rid of 2x here. So you'll have 2x minus 2x will give us 0. So negative 5 is equal to, we have 7x minus 2x is 5x. Multiply or divide by the same quantity of both sides of the equation. So we have here, negative 5 equals 5x. You can divide it by 5 to come up with negative 1 is equal to x. And then interchange the two sides of the equation. So you now have x is equal to negative 1. Solving linear equations, our goal is to obtain an equivalent equation with x isolated on one side of the equation and a number on the other side. So we try now to solve for the linear equation 3x plus 4 is equal to 10. So this is the given equation, 3x plus 4 is equal to 10. Subtract 4 on both sides. So you have 3x plus 4 minus 4. This will give us 0 here, and this will give us 6. So now I have 3x equals 6. And then divide both sides by the coefficient of x, which is 3. Divide both sides by 3, you come up now with x is equal to 2. Now let's verify if the proposed solution, which is 2, makes the original equation true. We can do this by replacing x with 2 in the original equation. So you have 3x plus 4 equals 10, that's the original equation. Substitute x by 2, we have 3 times 2 plus 4, and verify whether this will indeed come up to be equal to 10. So in this case, we now have 10 is equal to 10. So that means to say that the original equation holds true for x equal to 2. Hence, the solution set is equal to 2. Simplify the algebraic expression on each side by removing grouping symbols and combining like terms. So that would be the first step in solving a linear equation. The second step would be to collect all the variable terms on one side and all the numbers or constant terms on the other side. The third step is to isolate the variable and solve. Then check the proposed solution in the original equation. Now let's have another example. Solve 5 plus 2 times the quantity 3 minus y closed quantity is equal to 4 plus 2 times open quantity y minus 2 closed quantity plus 5y. So the first step is to simplify the algebraic expression on each side. So say the given equation is this: 5 plus 2 times the quantity 3 minus y closed quantity equals 4 plus 2 times the quantity y minus 2 plus 5y. You can use the distributive property to solve for 2 times the quantity 3 minus y. So that comes up to be 6 minus, we have 2 times minus y is negative 2y. And on the other side, this is 2y, then 2 times negative 2 will give us negative 4. So if we combine terms, the like terms are 5 and 6 here on the other side. So we have 11 minus 2y. On the other side, 4 minus 4 will give us 0. And then we have 2y plus 5y is actually equal to 7y. The next step is to collect variable terms on one side and constant terms on the other side. So the simplified equation in step 1 is 11 minus 2y equals 7y. So if we add 2y on both sides, we will now have 11 minus 2y plus 2y equals 7y plus 2y. But minus 2y plus 2y will give us 0 here. And this one, 7y plus 2y, will give us 9y. So we now have 11 equals 9y. Then interchange the two sides of the equation and come up with 9y equals 11. And for the next step, we isolate the variable and solve for the coefficient of y. So 9y equals 11. Divide both sides by 9. We come up with 9y over 9 equals 11 over 9. Or simply, y equals 11 over 9. So what would be the next step? The next step would be to verify or check the proposed solution in the original equation. And how do we do that? We try to substitute y for 11 over 9. So again, what's the given equation? 5 plus 2 times the quantity 3 minus y equals 4 plus 2 times the quantity y minus 2 plus 5y. Substitute y for 11 over 9. You now have 2 times 3 minus, we have 11 over 9 equals 4 plus 2 times 11 over 9 minus 2 plus 5 times 11 over 9. And then, try to simplify the values inside the parentheses by getting the LCD. So we have now the LCD is 9 here. So we have 9 times 3 will give us 27. That's why we have 27 minus 11 over 9. And then this one here, 9 times 2 give us 18. That's why we have 11 minus 18 over 9. And we have 5 times 11 over 9. So when we solve for this one, we can simplify again the value 27 minus 11 over 9 as follows. So that is equal to 16 over 9. And we have 11 minus 18 over 9 is negative 7 over 9. So multiplying 2 with 16 over 9, you come up with 32 over 9. And multiplying 2 with negative 7 over 9 will give us negative 14 over 9. Multiplying 5 with 11 over 9 will give us 55 over 9. So again, we try to get the LCD, which is 9. So 9 times 5 is 45. That's why you have 45 plus 32 over 9. Then 9 times 4 here, the other side of the equation, is equal to 36. So I have 36 minus 14 plus 55 over 9. And then when you try to add the values, you come up with 77 over 9 equals 77 over 9, which is actually true. We need to say the solution set is 11/9. So we have here our exercises. Find the solution set of the following equations. I'll give you 2 minutes to solve the following. And after 2 minutes, let's see if you were able to solve these exercises. Okay, let's start to solve the following equations. For the first one, we can remove the parentheses and multiply 2 with x. So you have negative 2x. Negative 2 times negative 3 will give us positive 6. Then you have 6x minus 2x. Combine like terms, so we have 4x here. Next, we can subtract on both sides of the equation x. So we will have 4x minus x plus 6 will give us 3x on the other side plus 6. And x plus 8 minus x will give us 8 on the other side. And what's next? We can subtract both sides by 6 to isolate our x variable. So you will have 3x equals 8 minus 6, which is equal to 2. And then divide both sides by 3 to come up now with x is equal to 2/3. On the other hand, for number 2, we have the following solution. First, we try to get rid of the inner parentheses here and come up with the following. Negative 2 times the quantity s minus 5. Then minus of minus 4s will give us plus 4s plus 4 equals minus 3s. And then we try to group together s and 4s inside the bracket. So we'll have 5s minus 5 times negative 2. And then plus 4 equals negative 3s. And then distribute negative 2. Come up with negative 10s plus, you have negative 2 times negative 5 is plus 10. Then plus 4 equals negative 3s. Combining like terms, we have negative 10s plus 14 equals negative 3s. And then subtract both sides by, add both sides by 3s because it's minus. So add both sides by 3s and come up now with negative 10s plus 3s is equal to negative 3s plus 3s here. It will give us negative 7s plus 14 equal to 0. Meaning to say, negative 7s plus 14 minus 14 equals negative 14. So we get rid of 14 on the other side. We were able to isolate s there. So we now have negative 7s equals negative 14. And that should give us negative 7s divided by negative 7 equals negative 14s over negative 7. Meaning to say, s is equal to positive 2. So for our references, we have Blitzer College Algebra Essentials, the 5th edition, and we have Algebra and Trigonometry in the Department of Mathematics and Statistics. So our first lecture ends here, and we will proceed to the next lecture.